Here we are solving the volunteer's dilemma game, and there are basically 38 players. Each player has two actions. Either I can call the police, and I can choose not to call the police. Spelled incorrectly, sorry. And if I call the police, then I will get the benefit of the crime being reported because I called the police. However, I will incur a cost of reporting, basically the cost of picking up the phone and call the police. So there's a small cost, and the cost should be less than one. And that's one action. The other action is not calling. There are two situations. One is no one else called, so no one else called. In that case, I will not get the benefit, so the crime is not reported, and I don't have the cost. I didn't call, so I get zero. And if someone else called, then I'll basically free ride. So I will get the benefit without incurring the cost. So I get one. So the question here is basically solving for a symmetric mixed strategy Nash equilibrium. So we will make the assumption that it's symmetric because there might be asymmetric equilibria, but we are only interested in symmetric ones and mixed strategy Nash equilibrium. So basically, I'll assume everyone is doing the same thing, basically calling the police. Say not calling the police was probably P, and calling the police was probably 1 minus P. So again, I'm assuming everyone else is doing the same thing, so we can actually compute the probability of each case. And in order to find a mixed strategy, in order for someone to mix, I need to be indifferent between the two actions. So that's the key sentence here. So in order for a player to mix, the payoff from calling should be from call should be equal to the payoff from not call. So that's the key equation here. If I prefer one strictly than another, then I will not mix. So here, if I call the police, I will get 1 minus C for sure, so there's no uncertainty. If I don't call, then what's the probability that no one else called? It's because everyone else is not calling with probability P, and there are 37 other players, and we're assuming they behave independently. So in all mixed strategy Nash, we make the assumption that people are behaving independently. So 37 people, each one with probability P choose not to call the police. So all of them not calling the police at the same time will be P to the power 37. And here someone else called. You can add up the probability that the first guy called, second guy called, and so on, but that's way too complicated. I'll just say 1 minus the probability that no one called is just someone called, so I will just write it this way. So now we can solve it. So 1 minus C is equal to 1 minus P to the power 37. So P is C to the power 1 over 37. So now we solve the mixed strategy for everyone. Everyone will not call with probability C to the power 1 over 37. And the question is asking what's the probability no one reported. So basically, we want to find the probability that everyone is behaving this way. So it's P to the power 38, and we know P is this. So that's why it's C to the power 38 divided by 37.